各位贵宾，接下来让我们热烈欢迎 Fortinet 资安长 Mr. Phil Craig。Ladies and gentlemen, please welcome Mr. Phil Craig, Chief Information Security Officer of Fortinet。请掌声欢迎。
Good morning. 大家好。Congratulations to Taiwan for putting on an ever-growing CYBERSEC conference, and I'm very pleased to be here to tell you about some of the strategies that I've learned in my career in the U.S. government, public sector, and now with Fortinet in the private sector. And so I appreciate your attention today, and I look forward to spending some good time with you after this presentation as well. We have a lot of topics I hope to cover. They're listed here. I'd like to briefly tell you about my company, Fortinet, where I'm the Chief Information Security Officer, the CISO. Fortinet is one of the largest cybersecurity providers in the world, where we provide the fastest, largest range, and best integrated security you can find out there. But this is not intended to be a commercial for Fortinet. Instead, it's going to be a discussion about some of the things I've learned along the way in my different jobs. And it's not clear to me sometimes why I'm asked to speak to large, smart audiences such as yourself. Sometimes I think it's because I spent 30 years at the NSA, the National Security Agency, and I also spent time at the CIA. I spent time at the White House, at the Pentagon, and in those jobs, I learned a whole lot about the foreign threat, and I learned a whole lot about APT, Advanced Persistent Threats. And so I'd like to be able to share some of my lessons from that. But other times, I think I'm invited because I'm a CISO, meaning I'm living the dream. I have to make sure that our enterprise IT and our products that we sell to others has the right security while it's constantly under attack by others. And of course, the third reason I might be asked is because the very, very strong reputation that Fortinet has in that it sells to all major sectors across our world. It's a very highly reputable company. But regardless of where I've worked or why I'm invited, what I've learned is that you have to do cybersecurity at speed and scale. And the strategy that I used to use when I was in charge of cyber at NSA was something called the OODA loop: observe, orient, decide, and act. And you want to be able to go from observing to acting before you're caught. That's how we were able to do things in my old jobs at such a massive speed and scale. And we did that by connecting all our different capabilities over a message fabric. And we had really, really good context or shared situation awareness on which to do those operations. But one of the areas that we were falling short in the United States is trying to move the private sector along on the strategy for doing things at speed and scale. We started an information sharing initiative about 7-9 years ago, and it was intended to share fact of that there was a cybersecurity incident. And then we realized that that wasn't enough. We actually needed to share the indicators as well. And then it made more sense to share the mitigations. But ultimately, where we need to be able to abstract the mitigations in a way that they can be ingested by anyone, no matter what technology or architecture you have. And even better, you'll be able to automatically ingest it through automation as opposed to human-oriented techniques. And lastly, you'll take an integrated, automated response with the humans being out of the loop and the machines acting on the will of the person, acting on the intent of the person. Before I do that, I thought I'd share briefly what some of the emphasis areas within my government, the U.S. government. Like any large organization, it cares about breach protection, making sure that its systems and its information are appropriately protected. It cares about cloud migration. It cares about a lot of things you see up here. But it also has an additional role, which is helping to secure our critical infrastructures. And that's where I'm going to focus the majority of my time with you today, is on critical infrastructure protection and operational technology. The United States also cares quite a bit about preventing state-sponsored theft of intellectual property, the integrity of the election system, privacy, supply chain integrity, and something that I'll talk about later, international norms of behavior in cyberspace. But that's what I consider to be top of mind by the government in the United States, and perhaps you share several of these issues. So what's changed, of course, is the threat. Just a few years ago, maybe more than a few, we were mostly worried about theft of data, commoditization of that theft, things like that. But where we've quickly moved, of course, is that it's becoming more about industrial fraud and gaining an economic advantage for a country. And even worse than that, it's been about affecting our critical infrastructures to cause them to act in unreliable or unsafe ways. So we need to do something about that, the collective we. But this is what many of us see today. We see this huge wave coming at us, and we're almost in a panic. We see these unstructured attacks coming at us from all these different directions. But what we don't realize is that there's a much bigger wave just beyond that. And that bigger waves are the more advanced persistent threats that we need to worry about, especially in our critical infrastructures, where there'll be multiple stages to an attack, where it'll be blended from multiple sources, and they'll be very, very persistent and be hidden in ways that we just can't imagine. So what I decided to do is, instead of always looking forward, I decided to look backwards. And this diagram here, of course, is a computer-animated graphic. And it's designed to reflect an old saying that all roads lead to Rome. And this saying typically means that there's lots of ways to solve a problem. All roads lead to Rome. And sometimes it means the emperor is omnipotent. But there's another lesson that's a little bit darker that I'd like to talk about. And even though my last graphic was computer animated, this is an actual sign. If you ever go to Italy, it really does seem like all roads go to Rome. But these roads were the critical infrastructure of their day in the Roman Empire. And it's what Rome used to spread its culture and greatly increase trade across lots of different places. But it turns out that those same paved roads that Rome used to build its empire turned to be the downfall of the Roman Empire. Those roads are what the invading armies used to ultimately take Rome and sack Rome. So the critical infrastructure of their day wound up being Rome's downfall. And of course, we don't want to repeat that. So what we need to focus on a whole lot more is operational technology, OT. OT, of course, are the things that are used in many of our critical infrastructures, whether they be energy-related, water, etc. And I like to use this diagram because it helps people understand the different terms. At the most broad level, there's critical infrastructures, which we just talked about, the things that help us, help our governments run reliably, help our businesses and our personal lives run effectively. Operational technology, OT, is often used within critical infrastructure systems. However, many of us who've been in this business a long time heard of these other terms, such as ICS or SCADA. They're all subsets of OT, operational technology. And at its core, you have some very small sensors. Some people call them actuators. Those are the things that sit on switches and pumps and motors and things like that, centrifuges. And sometimes they're called industrial IoT. But I'm just using this chart to get a common terminology. And for many, many decades, these OT systems were very, very secure, and they safely and reliably provided the services that we've all come to depend upon. But the air gap is just about dead as a security technology, as a security strategy. The systems that used to be physically disconnected, these OT systems, are now connected. And that's being done for lots of different reasons, but mostly for efficiency. But what it does is it greatly increases your cyber risk exposure because you can come in from the IT systems into the OT systems. And if you don't believe it as being a reality, here's a picture of a centrifuge. I took this photo of a centrifuge, and look what's on the front of the centrifuge, a data port. So the air gap is dead as a security strategy for OT. We as a community need to do something about that, do it urgently and with a lot of determination. So what I'd like to offer you are some strategies. One of the most important things we can do is have a strategy that goes after three different problems. What are the known knowns? What are the known unknowns? And what are the unknown unknowns? All right, so what does that mean to cybersecurity? The known knowns is the malware and threats that we've seen before, where we have indicators of compromises or signatures, and when we see them, we stop them. We stop the known knowns. The known unknowns are the types of attacks that we're positive are out there, but we're not sure when they're showing up or where. So that's where you use, in cybersecurity, behavior-based analysis to go after the known unknowns. And lastly, there's those things called the unknown unknowns. How in the heck do you go after that? Unknown unknowns are things that you can't even imagine today. So clearly, if you can't imagine them today, you can't do something about them in a tactical sense. But what you can do is you can future-proof your networks for the unknown unknowns. And the way you future-proof your networks is building around the fundamental elements of cyberspace, which is speed and connectivity. So, of course, when the internet was invented 50 years ago, it was trying to do two different things: connect computers at speeds that were previously not capable, and connect numbers of computers and people in numbers much more richly connected than it was previously capable. So if cyberspace is built around speed and connectivity, then your cybersecurity networks better be built around speed and connectivity. Because if they're not, you're going to be constantly swimming against the tide. The second major strategy I'd just like to emphasize is integration. So I talked about speed, now I'm talking about connectivity. I talked to a whole lot of senior people throughout the world running large enterprises, medium and small enterprises. And almost all of them have bought too many products. Over the past 5 or 8 years, many of us have bought products that were considered the best of breed of their day, but they turned out to be point solutions, and they became too complex to manage. So there's a very, very strong trend to better integrate your networks, number one, so that reduces the complexity of your management, and it also reduces the human error needed to address that complexity. The third major thing I want to talk about is automation. And guess what? I showed you this chart earlier, and this is how you take the OODA loop: observe, orient, decide, and act. And this is how you do it from a defensive perspective. Remember earlier, I was talking about how do you do offense at speed and scale. This is how you do defense at speed and scale. You make sure you have all the right sensors, you have the right analytics in place, you have automatable courses of action, and you have the ability to do something about it with a mitigation. You connect that over a message fabric so all these things can work together as a team, and you inform it with shared situational awareness, information sharing. We have to use machines to do the things you're really, really good at. Machines are good at doing this stuff, Let's get the humans out of the loop and better leverage automation to do the things that machines are really good at. And the last of the major strategies I wanted to mention is the need to have this shared situation awareness over here. There needs to be something that informs you about what the threat's looking like yesterday and what's the threat looking like right now. At Fortinet, we have a back-end organization of over 200 people, and what they've been doing for upwards of 10 years is characterizing threats, the known knowns, turning them into signatures and indicators of compromise, and pushing them out over a message fabric. Good on us. We should be happy about that. Everyone should be subscribing to a major threat feed like this in countering threats in cyber-relevant time. However, what we've been doing for the past 4 or 5 years is machine learning. And I promise you that this is not PowerPoint machine learning. This is something we've been doing for a long time. We started with an empty repository of what attacks look like, and we started running files through it. And so we trained our system to come up with the features of malware, and that became our features repository of what bad things look like. Next, we started doing system testing, where we took that features repository and we started pushing good files and bad files through it to see what was blocked by looking at the repository, but then afterwards, checking to see if, in fact, the things that were blocked were blocking the right things. So the first phase was training your system. The second phase is testing your system. And now you're cooking with gas, if you know that expression. Now you can truly leverage machine learning, where you send files through it, it looks at the features repository, and it's automatically deciding if this is good or bad and putting it in the right bins. And after just a little bit of training, a little bit of testing, like I told you about, we're now evaluating billions and billions of outputs today, of inputs today, to determine if they are in fact malicious or clean. So it just takes a little bit of a learning curve, but after that you can be really, really efficient and effective in characterizing threats and automatically pushing it out there to those who want to subscribe to such a threat feed. So the fourth of the major strategies was making sure that you have a good threat feed. So I talked about future-proofing, I talked about automation, I talked about integration, and I talked about leveraging a threat feed. They'll serve us all well. All right, so those are some of the technologies, but what I'd also like to do is focus on what I call the soft stuff, if you know that expression. The soft stuff are the things where we have to embrace the people. So too many times, we as technologists, we go to our boss or perhaps the board of directors or our C-suite, and we talk about a risk. But unfortunately, maybe we're talking about a vulnerability as opposed to a risk, or maybe we're talking about a threat instead of a risk. So what we need to do better at when we engage our C-suite and our executives is be more precise in when we're characterizing a risk. A risk, of course, equals a vulnerability, a threat, and a consequence, a bad consequence you want to avoid. So I use these spider diagrams, these radar diagrams within my own company, where once a year I get with my executive team and we define the 12 bad consequences that we need to avoid. Because executives are really good at defining bad things from bad consequences, but not all executives are really good at understanding threats and vulnerabilities. So I get them to define what their bad consequences they want to avoid, and then I go off and I mitigate threats and vulnerabilities. But I share this with you today because I find it to be a very intuitive way of describing with managers and executives the different dimensions of risk. And you can see a small risk and a big risk. And this risk here, actually, I care a whole lot about this risk because there's a really bad consequence that might happen, even though there's not yet a big vulnerability or a big threat. So this is my tool I just want to share with you for how I engage my C-suite. And ultimately, what it uses is something borrowed from the OT community. It's using consequence-based engineering. It's identifying what are the bad things you want to happen, and you try and engineer those bad consequences out before they can happen. So this is the case where the OT people are informing the IT people how to do better things. Now, If you don't know what I mean by consequence, I'd like to show you some pictures of an accident that happened several years ago in the former Soviet Union at a hydroelectric plant. Now, this was not a cyber attack. I want to be very, very clear. The plant was shut down for maintenance, but they accidentally put in some wrong configurations on their SCADA systems in their OT, and it caused some bad vibrations, so things started operating at the wrong frequency. Water leaked in, and there was a massive explosion. That's a bad consequence. And I don't mean to belittle it, because a number of people died, and it cost a lot of money and time to get this plant back in operation. So when you're in the OT business especially, you need to define the bad consequences you want to avoid and make sure these types of things can't happen. Another part of one of the soft things I'd like to talk about is integration, not just of the technology, but integrating the people as well. Right now, we have different people in charge of cybersecurity, operational security, and physical security. And oftentimes, attackers find seams, they find gaps between these people, and that's how they get into their networks. So we need to better manage across physical, IT, and OT. I'll just very briefly run through some case studies of where this is working very effectively today. I'm not going to brief this chart, but I put it up here simply to mention, for those of you who are not in the OT business already, that there's something called the Purdue model. One of the worst things that we can do in our business as security professionals is walk into a group of critical infrastructure of OT people and start talking the wrong language, right? If you're from the IT world, you talk about the ISO 7-layer model. But if you're in the OT world, you talk about the Purdue model. And this is the Purdue model. It's not 7 layers. It's got different numbers and different things. But this is how you can insert cybersecurity inside the Purdue model to greatly increase the security and safety and reliability of OT systems. These solutions are available today. In fact, in my company, Fortinet, we're doing this at a very large scale in the electrical generation area. We're doing it with oil and gas. We're doing it with green energy companies. And of course, we're doing it in some areas that I think Taiwan cares about especially, the industrial automation. We're doing it both in manufacturing, we're doing it in the transportation sector, and we're doing it in the logistics sector as well. So I'm just trying to briefly inspire you to say, even though critical infrastructure and industrial automation, even though it seems like a really, really difficult problem to solve, we can solve these problems. We just need to be a little bit more disciplined about it by adopting some of the strategies I talked about earlier. Now, it turns out that OT isn't the end of the story. There's a new domain that I just started talking about. I call it sci-fi, cyber physical. It's where some different things are converging. And when I say converging, I don't mean the casual intermingling of technology where sometimes it seems like the cell phones we're walking around pretty soon are going to merge into our face. I don't mean that. I mean the strategic fusion of technologies and data that are going to allow us to do things that we previously thought was science fiction, the other sci-fi. And that's going to allow physical things and data from our IT systems to intermingle in ways that are unimaginable today. So I'd like to just do a quick history lesson and recognize that this is where computing came from. We started with very, very large computers, and that became diverse over the years. But ultimately, we started doing things called virtualization, and virtualization ultimately became the cloud, right? The private cloud, public cloud. And those large computers gradually got moved out to the edge, and that became endpoint, where we had desktops, we had laptops, we had tablets, and now we have smartphones. And the smart people connected those things, like I talked about earlier. So all those pieces of your architecture are well integrated and could do defense as a team. And you underpin that with threat awareness. That's pretty good cybersecurity right there. But the endpoint is going to get really, really interesting just in the next couple years. Specifically, though I've talked about OT today, the things that control our industrial automation and our critical infrastructures, that represents the first piece of this new physical domain. But IoT, as we know, is about to greatly proliferate in this domain. And IoT represents the lots of devices that are going to measure things like heat, temperature, color, proximity, speed, smell, you name it. It's going to measure physical-oriented things. So now you have OT, now you have IoT, and right around the corner is building automation. Our buildings, heating and air conditioning, our elevators and our doorways are going to be producing lots of data within this new domain out past the endpoint. A lot of interesting data. And what's going to supercharge that is 5G communications. Very, very fast wireless communication, which is going to allow these different types of physical-oriented systems to communicate richly. And so sci-fi, to me, represents an opportunity to say, it's no longer just about the core, the cloud, and the endpoint, but there's a brand new domain up here, starting with OT and progressing over there, and we need to get ready for that new sci-fi, cyber-physical domain. So in closing, I'd like to appeal to each person in this audience directly. What I mean is that, surprisingly, you individually and you as a group have a lot of power to shape cybersecurity policy in your country, in other parts of the world. We can do the best strategies and the best technologies, and I talked about a lot of them earlier, but unless we have some cybersecurity culture in our world, we're forever going to be fighting a losing battle. And what I'd like to propose are 4 norms of behaviors in cyberspace. Number 1, countries shouldn't steal companies' intellectual property. Should be against the rules internationally. Number 2, countries should not attack other countries' critical infrastructures. Shouldn't be allowed. Number 3, if there's an international law enforcement investigation on a cyber security matter, you should cooperate. And lastly, do not undermine supply chain integrity. It's too important to the rest of the world. Now, I have 4 things that I believe in pretty passionately. You might have others, but even if you see one of these things up here, or 2, or 3, or 4, or a 5th one, I encourage you to talk to your governments, talk to your peers, and advocate for some type of norms of behavior in cyberspace so that we always don't have to rely on the technology. We ultimately rely on the people to use good behavior and good judgment. The second ask I have of this audience is do something to help to generate the next generation of cybersecurity and sci-fi professionals. I borrowed a model, believe it or not, from 700 or 800 years ago. It's called the guild system. It's where you have lots of apprentices who have very little skills, but they're mentored by higher level people, higher skilled people, and they become journeymen. And those journeymen become masters. We need to create a guild model for cybersecurity, but we also need to do it so it integrates IT, OT, and physical security. My company is trying to do its part. We have something called the Network Security Expert Program. It offers free training all the way from the novice level to the very, very top. But ultimately, it's going to take you and you and you to inspire your child or some other person, young adult in your life, inspire them to get into this business so we can have a more educated workforce for the future. I think that's on every person in this audience to challenge a young adult or a child to get them into this business. So, in closing, my takeaways is that the future is bright. I don't want to dwell on the threat and all the bad things that are happening and could happen even worse. That's important because with these great opportunities I described in the core, in the cloud, in the endpoint, and in sci-fi, they're great opportunities to make people's lives better. But there's also great responsibility to make sure that we get that right. My second takeaway is to ask you to adopt broad, integrated, and automated technologies. That's how we're going to be able to do cybersecurity at speed and scale. We need speed and connectivity. We need good segmentation done with agility. We need visibility, and we need to reduce complexity. Number 3, we need to make sure that our critical infrastructures are addressed with much, much more urgency. There's too many bad countries out there who have their sights on our critical infrastructures and critical manufacturing, and we need to do more about that. And it's simply, and not only is that important, but if we really are going to go into that sci-fi universe I talked about, it makes it even more important to start protecting these OT and physical-oriented things. And lastly, I just want to note that I think we have a responsibility. As I mentioned earlier, we need to develop the workforce of the future, and we need to develop the norms of behavior internationally. And with these things, optimism, technology, critical infrastructure protection, and personal responsibility, I think the future will be a bright place. So on behalf of Fortinet, I thank you for your time today, and I enjoy hearing from you later on. Thank you very much.
Thank you, Mr. Phil Cray. 谢谢讲师为我们带来的精彩分享。